All right, so let's start section 8.3. This is actually a pretty long section, and if you're in class, we break it up into, I think, 3 different days or more. So just to give you a heads up on that. So this is all about finding missing leg lengths of a right triangle, and then at the very end, we're going to talk about how to find the angle measurements as well. So let's get started with, before we get into all of the actual functions, let's talk about parts of a right triangle. So you have a right triangle, and let's call this x, okay? So that measurement is x degrees. So that is going to be your angle right there, okay? And so then whenever we have also the hypotenuse, of course. Okay, so that's the hypotenuse. All right, and then you have 2 other sides. You have the opposite side and the adjacent side. So whenever I say opposite and adjacent, I mean the side that's opposite and adjacent to the angle. So how I tell people to do this is I say take a put a dot in your angle and draw it, cut that angle in half and draw the line to the opposite side. And that is literally the opposite side. Okay, so that's how you do that. So you don't have to do that part, that's just something I do. And if that's the opposite, then this must be the adjacent. And if you didn't know, the word adjacent means next to. Okay, say I had the same triangle-ish, but my angle moved. My angle was up here. Okay, so x degrees. You would do the exact same thing. This would be your hypotenuse. I would tell you to take a line and cut that angle in half, and then that connects to your opposite side. And then what you're left with, the side next to the angle, is the adjacent side. Okay, so that's how you find the different parts of these right triangles. So now we have all of this, sine, cosine, tangent, all of that. So all of these are ratios, and there is actually a cool acronym to, it looks crazy, but it's cool. So it's called SOHCAHTOA. Okay, and I would definitely have this written down. This can help you memorize this. So the S in SOHCAHTOA stands for sine. So sine is the ratio of O is opposite over the H, which is hypotenuse. So opposite over hypotenuse is the sine ratio. The C in SOHCAHTOA stands for cosine, and that is the ratio of A, which is adjacent, over H, which is hypotenuse. And then the last one, T, is called tangent. It is going to equal to opposite over adjacent. So those are the 3 trig functions. And if you can remember at least the SOHCAHTOA to help you get here, it's going to help you. Another thing, some people I notice want to say sin and cos and tan. Try to use their actual mathematical names because you are an educated person. Sorry, this is a pet peeve of mine. So try to get used to saying them correctly just because you are educated. You can do this and make yourself sound educated. So we're going to find the sine of u and the sine of w. Write each answer as a fraction and as a decimal rounded to 4 decimal places. So let's first start with u. So the sine, actually let's do it in red. So the sine of angle u, remember sine is going to be opposite over hypotenuse. And if you need to reference back to this, no shame in that at all. I would too if I were you. So now we have our side, or our angle u is right here. So we need the opposite side of u. So I'm going to take a line and draw it. So there is our opposite. So the sine of u is going to equal the opposite side, which is 16, over the hypotenuse, which is 34. So stick that in your calculator. You do need to reduce if you can. So this does reduce down to 8 over 17. You can divide them both by 2. And they also said they want it as a decimal rounded to 4 decimal places. So you're just going to type that in your calculator, 16 divided by 34, or you could say 8 divided by 17. It's going to give you the same thing. So we have 8 over 17, or the decimal version is 0.470, and you're rounding to 4 decimal places. So it says in your calculator 5/8, so this should be 6, because that 8 causes it to round up. So that is one answer. And if you are watching this, make sure you're pausing and typing it in your calculator just to get used to it, so that way you know what you're doing when it comes time to do the homework. Okay, so now the next part they wanted you, I'm going to erase all this, they wanted you to find the sine of W. So we're going to do the exact same thing, but this time we're going to do angle W. So the sine, the sine of W is, we're going to still do opposite over hypotenuse. So take your line, cut that angle in half. There's your opposite side. So we're going to have 30 over 34. And I believe you can reduce that. Yes, you can. That turns into 15/17. And then the decimal form would be 0.8824. Okay, let's move on. So now let's do cosine of S. So cosine is, remember, adjacent over hypotenuse. So we're going to do the cosine of angle S is going to equal, if we're talking about S, let's draw to find our opposite side. So our opposite side would be right here. We don't want that one. We want the adjacent side. So that would mean 45. So 45 over my hypotenuse is 53. Okay, can you reduce that? I don't believe you can. No, you cannot. So we're just going to leave it like that. But then we will put it, because they want rounded as a decimal, rounded to 4 decimal places as well. So that would be 45 over 53, or 0.8491. So that's the cosine of S. Okay, now we're going to do the same thing, but we're going to use cosine of R. I don't know why that won't be. There it goes. Okay, so let's do the cosine of R, and R is right here. So we have the cosine of R. Remember, we're doing adjacent over hypotenuse. So I'm going to start at R and find my opposite side. Opposite is 45. We don't want that one. We want the adjacent. So that would be 28. So the adjacent side has to go on top. So 28 over 53. Can you simplify that? Nope, I don't believe you can. All right, so then let's see what it is in decimal form. So 28 divided by 53 in my calculator gives you 0.5283. Okay, if you're getting something totally different and you're typing it in exactly like, oh, actually, just kidding, not yet, that comes later. All right, let's do one more of these problems. So now we're going to find the tangent. So remember, tangent from SOHCAHTOA is opposite over adjacent. Okay, so let's first do the tangent of S. We're looking at S. So the tangent of S, opposite of S, opposite side would be 60, so it would be 60 over adjacent. You don't want to do 65, that's the hypotenuse. So adjacent would be 25. All right, and that reduces down to 12 over 5. Okay, so 12 divided by 5 is 2.4. Okay, last one, let's do the tangent of r. Okay, so we need to find the tangent of r. I'm going to take my r and find my opposite side. That one goes on top for tangent, so it would be 25. Over my adjacent side would be 60. All right, and that reduced down is 5 over 12, or just simply, what is that? 5 divided by 12 is 0.4167. Okay, so that is all for day 1. So if you're just doing day 1, then stop. All right, day 2. I'm actually going to skip this problem right now and go on to this one. I will come back to that one in a second. So we are going to find the height, h, of the lighthouse to the nearest foot. So this is actually like what engineers and people do in real life. They use this stuff. I didn't just make this up because I'm crazy. Okay, so we have our angle. So our angle is right here, and that's 62 degrees. And they want us to find that side where the h is. So which side is that? Well, if I take my line and draw it, it connects to the opposite side. So this is the opposite. This would be the hypotenuse, and this is the adjacent. So they give us the adjacent side, and they want us to find the opposite side. Okay, which function has opposite and adjacent? Well, we're going to be using tangent. So this one's a little bit different than what we did yesterday. So we're going to have the tangent of 62 degrees. You have to put your angle measurement there. Is going to equal, remember it's opposite over adjacent. So opposite over adjacent is what tangent is. So we need the opposite side on top, so that's just h. We don't know what that is. And the adjacent side is 100. Okay, so you're going to learn that when the variable is on the top, it makes your life way easier. It's only a one-step problem. So how would I get the h by itself? Well, I would simply multiply this by 100 over 1 because they cancel, right? So what I do to one side, I have to do to the other side of the equal sign. So now I have 100 times the tangent of 62. So I have 100 times tangent of 62 degrees is equal to h. So now I'm ready to just stick this in my calculator right here. So 100 times the tangent of 62. And if I'm going fast, pause your video and actually type it in your calculator. And it says round to the nearest foot, so that's whole number. So it looks like 188 feet is our answer. Okay, is that realistic that that's 188 feet? Yeah, it is, right? Okay, so let's do this next problem. You walk from one corner of a basketball court to the opposite corner, write and solve a proportion using a trigonometric ratio to approximate the distance of the walk. All right, that's a lot of words. That's okay. So we got this right triangle here. So here's our right triangle. And they give us this angle right here is 62. And they give us the side is 94. So that is going to be, they give us the opposite side, and they want us to find this x, which would be hypotenuse. So it looks like we're going to be using sine, because it has opposite and hypotenuse. So the sine, remember, is opposite over hypotenuse. So we're going to plug everything in. So I'm going to have the sine of 62 degrees is going to equal my opposite side, which is 94, over my hypotenuse side, which is just x. Okay, so now here is where I said if the x is in the denominator, it gives you have to do an extra step. Don't worry, I'm going to teach you how to do it. So we're actually going to do the same first step that we did the last time by multiplying both sides by what's in the denominator, x. Because we don't want to leave our x in the denominator in the long run. It's not good. We won't be able to solve until we get it out of there. So if you notice, those cancel. And on the left, you're left with x times the sine of 62 degrees is going to equal, all that's left over there is 94, right? Okay, what do I need to do to get the x by itself? Well, right now it's x times the sine of 62, so we need to do the opposite and divide both sides by the sine of 62 degrees. So those cancel, and you're left with x equals, and now you're just going to type this right here in your calculator. 94 divided by the sine of 62 degrees. And you get, it says round it, approximate, let's go 1 decimal place. So in my calculator, it shows me 106.5. Again, please pause the video and practice typing this stuff in your calculator. All right, let's go back to this one up here now that we're ready to solve it. Okay, use tangent. So they tell you right off the bat you're going to use tangent. They don't need to because we could figure it out. But to find the leg length. So they are telling us we're going to use tangent, which is opposite over adjacent. Okay, so here, draw a line, split our angle in half. There's our opposite side. So we're going to have tangent of 31 degrees. It's going to be opposite side, which is 17 over x. Okay, unfortunately, the x is in the denominator, so we're going to have to do the extra step. It's okay. So start by multiplying both sides by x. So they cancel over on the right, and you're just left with 17. Over on the left, you have x times the tangent of 31 degrees. Okay, we're trying to get the x by itself. So the first thing we have to, or the next thing we have to do is divide both sides by the tangent of 31 degrees. Okay, these cancel. So you have x equals 17 over the tangent of 31. I'm going to stick that in my calculator, and I get x equals 28.3. Okay. One last one. All right, so a railroad crossing arm that is 20 feet long is stuck with an angle of elevation at 35 degrees. Find the lengths of x and y. So it doesn't matter which one you choose first. I'm just going to go ahead and pick x to solve. So you have your angle right here. That's 35 degrees. And they give you the side 20, which is the hypotenuse. And then we're trying to find x, which is the opposite side. So opposite and hypotenuse would be sine. So you would do the sine of 35 equals the opposite side, which is x, we don't know what that is yet, over 20. Okay, so now that we got it set up, we're ready to solve. Multiply both sides by 20. Okay, so that's 20 over 1. Those cancel. And you're left with x on this side. And over here you have 20 times the sine of 35. All right, so we are ready to stick it in the calculator because the x is by itself. So pause the video and do that. Let's go ahead and round it to 1 decimal place. So x equals 11.5. And again, please type this in your calculator so you are practicing using this. Okay, now the next one we need to solve for is y. So we know this is 11.5, but we need to find the y side. So we have a couple different options. So we could use cosine because we have adjacent and hypotenuse. Or the other option would be to use tangent now that we know that this is 11.5. The reason why I'm going to ask you to avoid using this side is because whenever we found this, we had to round. And so we're gonna get a more accurate answer if we go with the number that we didn't have to round, which is 20. So in this case, I'm gonna go ahead and use cosine. So we're gonna have the cosine of 35 is going to equal the adjacent side, which is y, over 20. All right, let's get the y by itself. So I'm gonna multiply by 20 to both sides. So that's 20 over 1. Those cancel. And you have y over there. And over here you have 20 times the cosine of 35. All right, let's go ahead and stick that in your calculator. And it looks like you get y equals 16.4. Let's throw some labels on there for fun. Okay, if you're just trying to watch the second day's video, stop there. All right, so the very last of this is day 3 of video. We are talking now about how to find the angle measurements. So on the other ones, whenever you use the regular sine, cosine, and tangent, you're trying to find the side. Okay, so let's write that down. So when you use sine, cosine, and tangent, those are used to find a side. Okay, now I'm introducing a new one. It's called the inverse. You could say inverse tangent, inverse sine, inverse cosine. They all have an inverse. So whenever you do that, you write it like this. It's like tangent to the -1 power degree. It's kind of weird how they write it, but that's how you write inverse. So you use the inverse whenever you are, so the inverse sine is how you say it, inverse cosine, and inverse tangent. And these are used to find an angle. Okay? So, it's a little different, but it's actually kind of easy. So let's first work on these first two. Might not make a whole lot of sense to you until we start doing it. But once this is just getting used to putting it in the calculator. So we said let A and B be acute angles in 2 right triangles. Use a calculator to approximate the measure of angle A and angle B to the nearest 1/10 of a degree. So 1 decimal place. Okay, so on this one, we're trying to get the A by itself. And some people may want to start dividing by sine, but you can't divide by sine because there's no degree with it. So that's not going to work. So you're going to have to do this. So you're going to have to take A equals, and this is where the inverse sine comes into. So you're going to do the inverse sine of that number. So in your calculator, it can be a little weird. If you're using the Desmos calculator, you're going to have to hit functions, FUNC, and then you should see it because you make sure you have the -1 exponent on the sign. Otherwise, it won't give you the right answer. So depending upon your calculator, you might have to Google where to find it. Say whatever type of calculator, where is inverse sine, and it'll show you. Or ask me in class. Okay, so we type this in our calculator, and you get A equals 49.5 degrees. Okay. So now let's do the cosine. So it's the exact same thing. We need to get the B by itself. So in order to do that, B is going to be the inverse cosine. I probably should have I did put parentheses. Whenever you type it in your calculator, parentheses pop up. So 0.17. So same way, except this time we're doing inverse cosine. So you're going to type that in your calculator, and you get B equals, what is that, 80.2. Again, make sure you're typing this in so you're getting used to the calculator. Okay. Now this one might make a little bit more sense because it's actually showing you a picture. So it says use a calculator to approximate the measure of angle A to the nearest 1/10 of a degree. So we're trying to figure out what this angle right here, angle A, is. Okay, I want you to guess in your mind or maybe out loud, how many degrees do you guess that's going to be? Well, I'm going to guess 35 degrees, okay? It's an acute angle. I know it's going to be somewhere around there. Okay, so now let's look at the sides they give us. They give us 16, which is the opposite side, and then they give us 20, which is the adjacent side. So opposite and adjacent would give us tangent. So how we set this up is you write the tangent of angle A, we don't know how many degrees it is yet, equals the opposite side goes on top, 16 over the adjacent side, 20. Okay, so here you can reduce 16 and 20. You don't need to. You're going to get the same answer on this, so you do not have to reduce. If you really want to, you can. I won't, though. So now I need to get the A by itself. Just like on the last one, I'm going to solve it just the same way I did. So I'm going to take this and move it over there. And when I do that, A equals the inverse tangent of 16 over 20. Okay, so now it is a fraction. That's okay. The other ones were decimals, but you can do a fraction. So in your calculator, you're going to type in inverse tangent of, and the parentheses should already open up, 16 divided by 20. And so that means angle A equals 38 point, it said one decimal place, so 38.7. And that was pretty close to what I guessed, right? About a 30-something degree. I said 35, I think. So it's a 38.7 degree angle. And that makes sense for that. Okay, so now here, what is the measure of angle X, this one, to the nearest degree? So that's the whole number. It'll make it a little bit easier maybe. Okay, let's talk about what they give us. They give us this side, which would be the opposite, and then this side, which would be the hypotenuse. So opposite and hypotenuse is going to be sine. So we're going to have the sine of X equals our opposite side, which is 6, over our hypotenuse, which is 10. Okay, now we need to get the X by itself. So let's move that over. And when we do that, you take the inverse sine of 6 over 10. So type it in your calculator. And you get X equals 30, I said whole number, so 37 degrees. And that seems realistic for that problem, right? Looks like a 37-degree angle. Okay, let's do the last one for the notes for the 8.3. This is like the longest video ever. Okay, so we're trying to find X again, is what the directions said. So angle X. So it looks like they give us 15, which would be the adjacent side, and then 20, which would be the hypotenuse. So adjacent and hypotenuse would be cosine. So the cosine of X equals, adjacent side goes on top, 15 over 20. Okay, so now we're trying to get the X by itself, so let's move that over. So X equals the inverse cosine of 15 over 20. And type it in your calculator. And you get X equals 41 degrees. So 41 degrees is your answer. And that is it for section 8.3. Thanks for watching. Have a great rest of your day.